This is the last video segment on variable control charts, and obviously this is a rather unique situation. What we're looking at here actually are three charts in one. It's the individual X, the moving average, and the moving range. I'm coming back to those in just a minute. Fundamentally, these charts are used when you have a subgroup size of 1. Just like all the other variable control charts, they require that we have measurable data. But here we have a subgroup size of 1. In respect to where that would happen, many times you'll have an application where a single measurement will represent a process for a period of time. Suppose you have some form of chemical bath, and maybe once each shift or once each day you monitor or assess the chemical concentrate of that bath. That would be a single measurement. You wouldn't have to be doing that every hour. You might do it once a day. Or maybe you have a monthly financial value that comes up once a month. Or perhaps you have a situation where you're doing destructive testing to get this information, and it's a costly item. And anytime we do destructive testing, we're destroying a piece of goods, so we don't want to do that terribly often. So those would be typical situations where you would be using one of these types of control charts. Now, we're going to use them in combinations. For example, if I do the individual X, the IX chart, I'll also do a moving range. And like any other control chart, you have the averages and the range. If, on the other hand, I were to do a moving average, I would do it in conjunction with the range. So identical to other variable control charts that we've looked at, whether it's the X bar and R or X bar sigma, they're both going to have an averages scale and a ranges scale. So we have to do those two. What I've got here to try and explain this to you is an example. Let's say that we have a company that makes portable tables. You know those tables you can buy, they fold up and they have a little handle you carry around on them. And we're concerned about the handle. Perhaps the handle is riveted to the table, and we know that it has to sustain a certain amount of weight. So periodically, we're going to destructively test one of these. We're in essence going to put it in a tinsel testing machine or some kind of machine, and we're going to actually pull the handle off the table and see how many pounds per square inch it takes to do that. So I've set up 5 subgroups, 1, 2, 3, 4, 5, just as an example. And I'm going to start off with my individual X value. Now, these values are simply the measured PSI, or pounds per square inch, that it took to tear that handle off the table. So on the first one, 5.2, 4.9, 5.0, 5.1, 4.8, they're simply the individual PSIs for what it took to get that handle off the table. I can use that now with this, or I can choose to do a moving average. When you do a moving average, you have to decide on what they call the cell size. W is the variable that is used to represent the cell size. So for the sake of example, I'm going to use a cell size of 3. Now what that means, let me show you how these values were arrived at. To get the first value, I simply used the value in subgroup 1. To get the second value, what I did is I used the average of 1 and 2. And then to get to the third value here, I used the average of 1, 2, and 3. So now I've arrived at my cell size of 3. This next value is going to be representative of those 3. The next value is going to be the 3. So you're always looking at this one plus the 2 previous, which is why we have to start off a little slower to get to that point. But once we get to the cell subsize, then we continue. So in essence, every value here is looking at the current reading for that subgroup plus the previous 2, then the 3 of them averaged. If I had a cell size of 2, I would have then hit my cell size right here, and then this one would have been these 2, this one would have been these 2, and so forth and so on. So that's all it is. It's easy to set up in a spreadsheet. It's not terribly difficult to do, but you have to adjust the cell size. Typically, from what I've seen with these charts, the most common cell size is 2 or 3. Moving range. All right, now what they want to do with the moving range is I can't do it here in the first subgroup. I have to do it starting in the second subgroup. I want to know the difference between these two. So it's a matter of subtracting one from the other. If you'll recall, when we looked at the standard x bar and r, because I had a subgroup set of, say, 4 or 5, I would take a look at the high of that set minus the low of that set. Well, here I just have two values, so to try and do a high-low doesn't make a lot of sense. The simplest way to do it is to simply take this one minus this one, take the absolute value of this one minus this one. And if you recall, what the absolute value does is absolute value does not care about whether the number is positive or negative. It simply takes a look at the number of units involved. So if we were to calculate a negative value, it wouldn't matter. It would simply show it as the number of units or the positive value. So the easiest way to do this is simply to take, this is, okay, using our notation, this would be Ix sub j. And from it, I'm going to subtract Ix sub j minus 1. Okay, so I'm going to subtract, okay, this one from this one, and that's going to leave me a negative value of 0.03, but the absolute value function is going to make it as a positive 3. Here I'm going to subtract from here to here and on down the line. So in essence, I will have a range of these two, and then of these two, and then of these two, and then of these two, right on down the line. I won't have one here because there's nothing behind it to use for that. So the moving range always excludes the first subgroup. All right, looking at the bar, the average calculations, Ix bar, Ma bar, and the Mr bar. Now this is no different than what we've been doing in the past. We're simply saying that the Ix bar, the individual x bar, is equal to the sum of all of the Ix values. Okay, 1, 2, 3, 4, 5 in this case. So this would be 1 through 5. That sum then divided by k, which is the number of subgroups we have. You've seen that before, so that's pretty straightforward. The moving average, the Ma bar, is simply the same as the Ix. We're going to use this value for this one, so we really don't have a different calculation to do here. The moving range, all right? Now, if we note the new moving range, and it looks like moving ranges in the past, except for one little exception, notice it says we're going to get a sum of all of the range R sub j's from 1 to 5. Well, there's nothing here, right? But I have 1 plus this, nothing plus this, plus this, plus this, plus this, which means when I get all done, instead of 5 subgroups, I only have data from 4, which is why you see down here the k minus 1. All right? So those are giving our bar values, or our average values that we'll need. And in the respect to all 3 of these charts, these guys are going to be the central line for the chart. All right? Control limits. All right, and I've just combined these into one since we've looked at them so many times. The upper control limit for the Ix and the lower control limit for the Ix. It's simply the Ix bar. If it's the upper, it's plus the product of the A2 value times the Mr bar value. If it's the lower, then it's the Ix bar minus the product of the A2 times the Mr bar value. Now, if you take a look at the factors or the constants for control charts in the back of your text, you will see that in that book, they do not show a subgroup size of 1. And these are all subgroup sizes of 1. Subgroup size for A2 of 1 is 2.660. Now that's not in your book. You'll find that in other charts. So you might want to take particular note of that. Now, the upper and lower control for the moving average is the Ix plus or minus the square root of standard deviation times x over the square root of the cell size. All right, this is not as hard as it appears to be. The sigma x, or standard deviation of x, is simply the Mr value, the Mr bar value, which would come from up here, the Mr bar value divided by the D2 value. And again, the D2 for a subgroup size of 1 is 1.128. Okay? Again, take note of that. It's not in the table in your book. If the cell size is 3, then I'm simply dividing the product of these two guys by the square root of 3, taking the square root of the whole thing and either adding it to or subtracting it from the IX bar value. Finally, the upper and lower control limits for the moving range. We separate these because there's a little bit of difference here. The upper control limit for the moving range is simply the MR bar value times D4. As with the others, the D4 value for a subgroup size of 1 is 3.267. Take note of that. Again, it's not in the chart in your book. Lower control is real simple. The lower control limit for the MR moving range is always 0. So, like I said, initially, a lot of people, it looks harder or more complex than it is. It really isn't. Don't overthink it. We're just looking for an average here. We're looking for averages here, but we're getting them out of every sets of 3. And we still have to do the first one by itself. The next one simply represents those two. And now we've hit our cell size of 3. So everyone from here on is looking at the one plus the previous 2, so a cell size of 3. If you were doing, for some reason, a cell size of 4, we wouldn't hit our final cell size till here. As I said, if you were doing a cell size of 2, we would have hit it here. Now, you don't mess around with the cell size on this. The moving range is always simply the range between the two subgroups.